Bismillahirrahmanirrahim. Assalamualaikum and good day everyone. My name is Muhammad Al Hakim and I will be presenting task 1, which focus on the application of the quadratic Lagrange interpolating polynomial using tenaga nasional berhad stock price data. The objective of this task is to estimate the stock price at specific dates that are not directly available in the given dataset. The stock price dataset was extracted from the MSN Finance website for the period from May 2025 to April 2026. Based on the instruction given, 1 month is assumed to be equivalent to 30 days, and the corresponding day indices were assigned accordingly. From the given link, fill up table 1 with related values, assuming 1 month equivalent to 30 days only. So I was extract the data from the chart, from the graph, and for solving this first A question, I was extract and fill the table, and this is the extracted data from day 1 into day 331 with the Y value from the official website graph. And to solve the first question, which use the quadratic Lagrange interpolating polynomial for the given values in table 1 in A to approximate y equal to fx for June 5, 2025 and March 11, 2026. Okay, first we highlight here quadratics mean we will use degree 4, which on this question, look at the first question. Alright. In June 2025, we assume from the table June 2025. In 1 June 2025, it start with day 31, and then for 5 June we assume as day 35 from 1 June to 5 June, 31 and day 35. We collect 5 points from the data in the graph for solving this question, and we will find P for x, which x here is 35, and use the formula y0 L0x plus y1 L1x, and then so on until y4 L4x. Okay, first we need to find L0 until L4. For L0, we use the L formula and we got negative 0.02486, and for L1, use the L formula and we got 0.88331, and for L2, we substitute x into this equation, which 35, and we got 0.20217, and for L3, I already calculate it, and the answer will be negative 0.06252, and for L4 I got 0.00190, and after we collect all L1, L0 until L4 value from the equation, and we substitute it into P4 equation. This is the formula, and we substitute it y0 which 13.86, and we substitute the result from L0 and so on, and the final answer is 14.2022, 6 and 2022. This is the data, estimated data for 5 June 2025. And then for 11 March 2026, we assume that the day on that day is 300 day 311, which we start from 1 March, which 301, and next in next 11 March it will be 311, day 311. And from the graph I collect 5.5 data, which will be used to find this value, the value on this day. Also, we use the same formula. We will find P4 x, which x here is 311, and from the same formula we need to find L. For L0 we got negative 0.02881, and for L1 we got 0.16461, and for L2 we got negative 0.43210. For L3 we got answer 1.15226, and the final L is L4. We got 0.14403, and then after we collect all L values, we substitute it into a P4 formula, which this is Y0 and this is L0 result, and then this Y1 we got from this table, Y1, Y2, okay. Okay, L1 we got 0.16461, and L2 we got negative 0.43210, and L3 we got 1.15226, and for last L4 we got 0.14403, and for P4 formula we substitute all of L from L1 until L4 into the P4 equation, and we got 14.45854. And for the conclusion, we need to find the difference and what is the error from the estimated value and the exact value. For 5 June 2025, from the official website, I got the data which 14.20, and from our calculation for 14.2022, and for the absolute error with the exact value minus our calculation 14.22622, and we got the absolute error is 0.02622. And for 11 March 2026, from the official website, from the graph, I got the exact value for the stock on that day, on this day, is 14.24, and which our calculation we got 14.45854, and the absolute error is exact value minus with our calculation estimated value, and we got 0.2154.
Next is task 2. Above is the graph showing the annual financial performance of two business companies known as Malayan Banking Berhad for the blue line and also CIMB Group's Holding Berhad for the red line. By using the following data in figure 2, we need to extract information for the graph monthly basis, then construct the Newton-Finite divided difference table up to the 5th order for the both company. So I got the table for the Maybank and also CIMB. For the Maybank, for the X, I get the value from first month is mean to 2 May 2025 until 1 April 2026. So we got the X value from the 1 until 12 months. So we got also the fx1, first DD, second DD, third DD, 4 DD, and also 5 DD. And also same for the CIMB. We got X is mean first month is May 2025 until 12th month 1 April 2026. So we got the fx1, first DD, second DD, third DD, fourth DD, and fifth DD. And the second question is calculate the Newton forward FDD polynomial P and X that pass through all the given point at x naught 1. X naught is equal is 1 for the Malayan Banking Berhad Company. So we use this formula P and X. So all the value of X naught we change to the 1. So we got this example. We got this answer. So third is calculate the Newton backward FDD polynomial P and X that pass through all the given point as X naught is equal is 11 for the CIMB groups holding Berhad Company. So for the third question is also for the same question for Malayan Banking, and for the CIMB we use the formula and we change the value X naught is 11. So we got this answer. So the question B is we refer to the same data. Use the method of discrete least square polynomial of degree 2 to fit a parabola for each company. So the question 1 is of degree 2. So we know this is the quadratic. So the formula is for the quadratic is Fn is equal A naught plus A1x plus A2x square. So we got the Maybank. We got x, y, xy, x square, x third, x4, and also x square y. So to get the value of A naught, A1, and A square, we use matrix form. So we use the calculator, and also to get the answer for the value P to X is equal 6.24659 minus 2.96777x plus 0.33006x square. And for CIMB we use the same. We got x, y, x square, x third, x4, xy, and x square y. So we total and get the value for each column, and also we use matrix form to get the answer of A naught, A1, and A square. So the value of CIMB, we got the P to X is equal negative 6.10591 plus 2.24016x minus 0.02068x square.
So this is task 3, is square approximation. So it has two questions, which is determine value A and B, and approximate for Y value, which is 3.35. So first step, we linearize the model according to the value and the model. So as we can see here, we have y square, y, m, and c. So the next step, we construct a table. So this is my table. I have it with label y, x, y, and x1 over x square, y equal to y square. This is based on the basic previous model. So as you can see here, here is my answer. So next we find M and C. So M is the slope of the point and C is intersection point. So for the fourth step, we find A and B. So using the model that we derive, M is equal to 1 over B. So we make it B 1 over 0.99 is equal to 100064. And then for model C is equal to A over B. So we make A is equal to C times B. So A equals to 2.000341. So basically A is equal to 2 and B is equal to 1. So for the next step, we find the value at Y 3.35. So we make X as same as 3.35, A 2.00341, B 1.00064, and we insert it into the previous model. So Y equal to 3.35 equal to set 0.00341 plus 3.35 square over 1.00064 times 3.35 square. So the answer is 1.08543.
Welcome. Good day, everyone. I will present task 4, which is continuous least squares approximation using Legendre polynomial. For this task, we need to find the least squares polynomial approximation of degree 2 for the function fx cos x plus 3x squared. This task has 3 parts: question 1, question 2, and question 3. Let's start with question 1. Question 1 asks, state the general equation of Legendre polynomial of degree 2. The general form of Legendre polynomial of degree 2 equation is P2x and A0 P0 x plus A1 P1 x plus A2 P2 x. Next, for question 2, identify a suitable linear transformation if necessary. For interval negative 1 to 1, no transformation is needed because Legendre polynomials are already defined on the interval negative 1 to 1. For interval 0 to 2, we need to transform it into negative 1 to 1 interval. We use x t plus 1, which t equivalently t x minus 1. This change the interval 0 to 2 into interval negative 1 to 1. Now, for question 3, part A, we find the polynomial on the interval negative 1 to 1. We use the coefficient formula an 2n plus 1 over 2 interval negative 1 to 1 and function of fx multiplied by px and dx. With the same formula, we substitute n equal to 0, and then for a0 and we substitute n equal to 0, we get a0 equal to 1.84147. And then for n equal to 1, we need to find a1 next. Since the function multiplied by x becomes an odd function, the integral over -1 to 1 is 0. Therefore, a1 will be 0. And then a2, n equal to 2. Use the same formula. Substitute 2 in a2, and the final answer for a2 is 1.68982. So the least squares approximation on -1 to 1 is p to x equal to 2.53474x squared to 0 plus 0.99659. Next question. Next, for question 3 part B, we find the polynomial of the interval 0 to 2. Since the interval is not -1 to 1, we use the transformation x t plus 1. So the function becomes cos t plus 1 plus 3t plus 1 square, and use the formula an 2n plus 1 over 2 integral -1 to 1 and function y t multiplied by p t dt. And after calculating the final coefficient we get for a0, a1 and a2, a0 we got 4.45465, and a1 we get 5.23973, and a2 we get 1.83241. Therefore, p to t therefore p to we got 4.45465 plus 5.23973t plus 1.83241, 1 over 2 3t square minus 1. After simplify, 2.74896 t square plus 5.23973t plus 3.53844 x minus 1, and then substitute x minus 1 into this final equation, and we get 2.74862x square minus 0.25751 x plus 1.04733. And the conclusion, the interval -1 to 1, the least square polynomial approximation is p to x 2.53474x square plus 0.97659 and for interval 0 to 2, the least square polynomial approximation is 2.74862x square minus 0.2575 1x plus 1.04735. This method is useful because legendary polynomials are orthogonal, which make the calculation of least squares coefficients simpler and more systematic. Thank you.